when we say application modernization, we have kind of a big application that we want to break up and maybe scale, or maybe you can say modernize. So in the sense, we have two kind of application development approaches. One is monolithic versus you can say microservices. A monolithic application puts everything that you need, your application, your libraries, your dependency, and the OS as part of, you can say, a single process. And if you have to scale your application, you kind of have to create multiple VMs for them, and you deploy your application as a process on those VMs. So while in the sense of a microservices, you just pack your application with this, you can say, dependency, and then each component or each logical component of your applications become a separate service, and then you can scale or distribute these services on multiple servers and scale them as you need it. So at a high level, application modernization is a approach where you split or migrate your legacy application. Here, when we say legacy application, we are talking about your monolithic application to a new platform. It can be like you are on a Windows and you want to move to a Linux or any other servers, and maybe an entirely different version of your application. Re-architecting, maybe you just want to redesign overall architecture of your application. You want to re-engineer some part of your application. You want to, you can say, replace some part of your application. Maybe you are using a on-premise databases, but you want to use a cloud databases kind of, and maybe you want to retire some part of your application. Just for example, you have a service that is not being used, or that service is just you can say deprecated. In those cases, you may also want to strip down your application from some features of the functionality. Okay, so when we say organization using API, it is in the sense that we have our monolithic application that is being running on some on-premise system, or you can say maybe on the cloud, but due to the time being, we are not capable, or we do not have enough budget or the bandwidth that we can break this big application into a microservice based application. So in those cases, we can use the API process to modernize our application. How it helps is it gives you faster way that you can go to market. It speed up your time to market. You can still leverage your legacy application, and you just need to define your new offering and the services into the hands of the customer, so that in this way you are not involved in a recording or re-engineering on the re-platforming of your application. You just define a API on the top of your legacy application, and this API just act as a proxy to your legacy application. Using the API-based approach, you can deliver dynamic customer experience. For example, you want to distribute only a few API to your customer, maybe infuse some customer-specific logic, that instead of changing the code or making some customer-specific changes in your legacy application, you can achieve the same in the APIs as well. This kind of approach also empower developers and the partner, so that from that API-based access, you can easily add new users to the partners instead of adding new users and the partner in your legacy application, and the handling based on those. All the authentications and the user storage can still be handled by these APIs, so that in order to add new users or the partner, you don't have to add kind of logic in your legacy application. Maybe you just want to add a new group of the user, new role in the application, that in your legacy application, you kind of have to add a business logic based on those new roles. But in the API based approach, you can add these roles using just a graphical kind of interface, using this API management tool, and then you can faster onboard, you can send new user onto this application. So when we say using APIs to modernize your legacy application, it kind of helps you in two ways. First, it helps you to define a different API layer on the top of your legacy application, which is shown as application 2, which is you can say monolithic application. So using this approach, you can define a API based approach on the top of your monolithic application, and this way you can access the other system or other micro services in the ecosystem, or you can say in the internet as well. The main benefit of using APIs is that you don't have to code anything. These APIs are typically defined in the form of YAML. At a high level, you can consider that these are, you can say, in the form of YAML that we define in a similar way, like Swagger, right? So you just have to define a kind of a YAML file. If you want to infuse some logic at the API layer, you can also define that logic either using the JavaScript or using the you can say Python script, or using even a Java program. So you can alter the response from this you can say monolithic application and present them in a different way. By modernization using API, which allows you to faster time to go market, you can then again use this API to interact with a variety of the customer. For example, if you have just a monolithic application and your application just being used either as a desktop application or the web API, but or you can say web application, using a modernization using API, you can again reach to a wider customer, maybe a wearable device, maybe an iPad, or you can say healthcare as well. And this way you can again alter the response of your API. When I say alter the response of the API, we can alter in the both way. Either I can change the response itself, alter it, modify it the way, or I can also change the response content time. For example, my monolithic application is just returning HTML or the JSON, but few customer may want to have this response either as a YAML or either as a XML, maybe, right? So that kind of feature is also I can add into my API layer. So to modernize legacy application using API, there are some recommended products and services on the Google Cloud. We can use APG. APG is again, you can say, market leader for the API management. Inside the APIG, you can do a lot of stuff. You can do the user management, API versioning, proxying, adding custom layer as well. You can package your APIs into a group of, you can say, into a multiple group. Like you can define a silver, platinum, or the gold kind of package for the API, and then you can monetize this stuff as well. You can say AI and the machine learning to modernize your application. For example, you want to infuse some sort of advanced ML to your legacy application, then using the AI ML to modernize, you can also achieve this. Anthos is again a great tool which you can use for the API based you can say management. It allows you to build a microservice where you can combine the application from on-premise and the you can see cloud as well. So if you have your legacy application running on the on-premise, you can use Anthos to define a API-based modernization approach where you can just have API proxy layer in the Anthos in the GKE form, and you can use Istio and you can see others to modernize your legacy application. using API approach. So these are the three other tool at a high level you can use to define a API based approach for your legacy applications. All right, so let's dive into the modernization using microservice. So modernization is not just that you break your legacy application and you define multiple API and still have those API as part of single process. That is not a you can say microservice. When we say microservices, these are the logical components that we organize our application, and these uh, applications and services then can be deployed separately, can be scaled, and can be changed independently. So what the typical approach uh, when we say we have microservice based application, we kind of tend to define, you can say, multiple APIs within our application. Maybe uh, you can say login API, then password API, then change password, and then maybe then you can dashboard API, you can say listing API. But even if we define them in an API manner, we kind of still tend to have them as part of a single process. For example, if we have a Flask API, we used to define this API as a separate API endpoint, but still that is a single Flask API, big Flask API that has a multiple endpoints in that. So that is not a microservice approach. Microservice approach says you bring down the authentication service out of your API and then deploy it separately. You have your listing or the bucketing or the, you can say, card API, and deploy and then develop this API separately, and then this API can then scale independently. So that is a microservice based approach, so that we can scale independently, we can develop you can say independently, and we can deploy them independently. Advantage of, you can, microservice based approach is, again, as I said, you can deploy your microservices independently. You don't have to deploy an entire bunch of your microservice altogether. Using microservice based approach, you can choose a different platform or the framework or the language for each of your service. For example, if you have a high traffic IO kind of API request for that service, you can use a different language, maybe a Node.js. If you want to use a different language for a different API, maybe a Python for a API and the Java for an API, the microservice-based approach allows you to do so. These API can be managed by different team. If you go with a microservice-based approach, you can have different team. You can say managing these API. So what usually happen in big teams? So we call this in the terms of, you can say, modules. In the big teams, each module is handled by a different team. You can consider these you can module as a part of a microservice where each team is responsible for just their own part. So using a microservice based approach, we can have different teams specialized in that, you can say, particular domain of that you can say microservice, and then it can innovate or scale or build more feature at a faster speed. One way of working or introducing a change in your microservice is to create a versioning of your API. Uh, so this is, again, a you can say one more advantage of going with a microservice space, that you can version your APIs as you introduce more changes, or that any changes will not impact the current use of that microservice. You can easily design for failure. Failure in the IT world or the software world, you can always happen, but it should not be like that. If your service fail, the entire application fail, right? So you can still a plan for the failure. You can task your service for the failure without impacting others, and That way, this is how microservices help you with your application development approach. You can characteristics of your microservices are basically you should break or componentize your microservices. You should break them into a logical component. They should be organized around business capabilities, not on some other you can say logic. These should be treated as products, not as a projects. You should have smart endpoints and the dump pipes, so this should be able to pipe with other services. Like in the Linux world, we kind of we can pipe the response from one API to other APIs, right? So for your REST API response should also be usable in that form as well. It allows you to have a decentralized governance, so that you have you don't have a single point of governance. So you can use a different team that is you can say managing your APIs, maybe different language of that, as we say. You can have a decentralized you can say data management instead of just using a single DB for all your you can say API. You can just use the best database, which is best for your API. So you don't have to stick to the you can MySQL for all your API. If you want to use Elasticsearch, which is best for your service, you can go with that. You can service it. It allows you to infrastructure automation in the sense you can use some sort of Terraform or others to deploy your microservices infra. Although you can do the same for the you can say with the monolithic application, but infrastructure mode you can automation kind of you can nowadays consider with the microservice based approach more. You can design your API for the failure. You can design your API for failure independent of the other service. You can load test independent you can service. You can all that is stuff you can do. It allows you to introduce some innovation in your API. You can introduce new features and new maybe AI/ML based approach into just your API, not impacting other you can say API on the team, right? And then the last is you can always refer to the 12-factor app guide, which allows you to what how different or the different but the steps that you should consider when defining a microservice. It allows you to, for example, you should you can say what's in your code. You should you can say design for the scaling also. So always refer to the 12-factor app guide when you are building a microservice. Application migration to cloud, the cloud can help you in much way for your microservices. It can definitely improve your performance. Like it allows you to use the best products in the you can on the cloud. For example, you just want to use a BigQuery for some analytic purpose, or maybe you just want to use a big table that so if you have this tool access on the cloud, you can definitely improve your application performance. The cloud helps you securing your data or securing your API. It can secure data on the fly on the RAS, and cloud is again much cheaper than the on-premise in you can say most of the cases.